The Bowditch's method consists of distributing error E among all the survey lines of the traverse according to their lengths. The lines of the closed traverse are laid out as a straight line and the ordinate A. A' is taken as equal to the closing error E. By drawing one line each at every traverse point on the straight line, so that all the lines are parallel to A', the corresponding errors B, B' to E, E' are obtained. The lines B, B' to E, E' are drawn parallel to A' upon the traverse with the closing error. The end points of these lines are marked B, C, D, and E, respectively. The traverse is then redrawn by joining A, B, C, D, E, A, so that the traverse adjustment is completed, without any closing error. So remember, by applying the Bowditch's method, the closing error is adjusted so that the ending point of the framework coincides with its starting point. In this module, you have learnt that traversing is a type of survey in which several connected survey lines of known direction and length form the framework. The importance of traversing is that it enables surveyors to accurately plot the shapes of ground features having an irregular outline. When the connected survey lines form a loop or a polygon around the ground feature, as in the case of a lake, it is called a closed traverse. When the connected lines form an unjoined pair along the ground feature, as in the case of a river or a road, it is called an open traverse. When the end of the last line of a closed traverse does not exactly meet the starting point of the traverse plotted on a map or plan, it is called a closing error. To rectify closing errors, some compass traverse adjustments, such as the Bowditch's method, are applied.
You have seen the errors that are possible when using a compass for land surveying. In order to avoid some of those errors and other mistakes which surveyors might encounter on the field, it is advisable to be aware of some do's and don'ts in compass surveying. So, what are these do's and don'ts in compass surveying which surveyors need to be aware of? Let's find out the answer by going through this module, Do's and Don'ts in Compass Surveying. Welcome. After completing this module, you will be able to list the do's and don'ts in compass surveying. The do's and don'ts in compass survey are basically a list of precautions to be taken in compass surveying. Let's find out what they are. To begin with, hold the compass in a level position always when fixing it to the tripod. Always tap the compass box after the needle has come to a rest to free the pivot of friction. Also, press the knob or pin to stop the vibrations of the needle. Don't bring metallic or electronic objects like keys and mobile phones close to the compass because the needle's movements will become affected. Then, remember to take the fore and back bearings of all the lines. When there is an obstacle between the compass and a survey station, always take readings from an intermediate point. Don't take readings from the wrong direction. Always take the duplicate readings at important stations to avoid errors. Let's summarize what to do and what not to do in compass surveying. These are some of the important do's of compass surveying that you must always follow. These are the don'ts that you must always avoid when using a compass.
You have seen that elevation at different points above a given surface can be determined by leveling. In order to determine the values of elevation accurately, we require the aid of some instruments. So, what are the instruments that help us to determine the values of elevation accurately? Let us find out the answer by going through this module, Leveling Instruments. Welcome. After completing this module, you will be able to identify the instruments for leveling. Two instruments that are required for leveling are a level and leveling staff. There are different types of levels and leveling staffs used by surveyors in the field. Let us take a look at what they are. The purpose of using a level is to find out relative heights. Any level consists of 4 parts: a telescope to sight objects on the ground, a level tube for making the line of sight horizontal, a leveling head to check and adjust the correct position of the device, and a tripod upon which the device is mounted. We can see these parts in the different types of levels, that is, dumpy level and Y level. The dumpy level is an optical instrument consisting of the following parts: telescope, eyepiece, objective, longitudinal and transverse bubble tubes, focusing screw, foot screws, leveling head, and screws for adjusting the bubble tube and the diaphragm. The dumpy level can be identified by its long, thin telescope mounted to the leveling head at one point between the 3 prominent foot screws. Now, let us take a look at the Y level. The Y level is an instrument with the telescope mounted in 2 vertical Y-shaped supports. Most of its parts are similar to that of the dumpy level. The Y level can be identified by curved clips that connect the telescope to the 2 Y-shaped supports. By raising these clips, the telescope of the level can be replaced with the position of its ends interchanged. So remember, the 2 different types of levels are the dumpy level, and the Y level. The dumpy level can be identified by its long, thin telescope mounted at a single point, while the Y level can be identified by its curved clips. A leveling staff is used to measure the distance by which a given station lies above or below the line of sight. Basically, there are two types of staffs: a self-reading staff and the target staff. The readings of the self-reading staff can be read by the person using the leveling instrument, while the readings of the target staff must be taken by the person holding the staff. There are three types of the self-reading staff. Let us take a look at each of them. The three types of self-reading staffs are solid staff, holding staff, and the Sopwith telescopic staff. The solid staff is a one-piece staff made of seasoned timber. It is 3 meters long. The left side of the staff is graduated by meters marked in red, and the right side is graduated in decimeters marked in black. The smallest division on the solid staff is 5 millimeters. Now, let us take a look at the folding staff. The folding staff is made up of well-seasoned timber that is about 7.5 centimeters in width, 1.8 centimeters thick, and 4 meters long. It is divided into two parts of 2 meters, along with a locking arrangement. It can be folded into a shorter piece when required. It is graduated in the same way as the solid staff. Now, let us take a look at the Sopwith telescopic staff. The Sopwith telescopic staff consists of 3 parts, arranged such that the lowest one contains another extensible part, which itself contains the extensible third part. The 2 shorter lengths can be pulled from and pushed into the longest length, so this staff is called telescopic. While the top portion of the staff is solid, the middle and the bottom portions are hollow. The middle and top parts of the staff are held in position by spring catchers. So remember, the 3 types of leveling staffs are the solid staff, the folding staff, and the Sopwith telescopic staff. Module, you have learned to identify the instruments for leveling. Instruments used for leveling are a level and a leveling staff. The 2 different types of level are dumpy level and Y level. You can identify the dumpy level by its long telescope mounted at a single point between the 3-foot screws. You can identify the Y level by its curved clips that connect the telescope to 2 Y-shaped supports. Different types of staff are self-reading staff and the target staff. The 3 different types of self-reading staff are the solid staff, the folding staff, and the Sopwith telescopic staff. We have already learnt the leveling is the process of measurement of relative elevations of points in vertical plane by using a leveling instrument. Before measuring anything in the field using a leveling instrument, you need to make some temporary adjustments in the instrument. Let us see what the temporary adjustments are and how to make those adjustments. The procedure for setting up of leveling instruments is as follows. First, set the tripod on the ground over the station mark. Then, holding the instrument in one hand, turn the leveling head of the instrument on to the tripod screw with the other hand. Spread the tripod legs to adjust the instrument to a convenient height. Then, drop a pebble from below the instrument onto the station mark so as to center the instrument accurately above the station mark. Now, fix any two tripod legs firmly into the ground and move the third leg circumferentially to bring the main bubble approximately to the center of the tube. So remember, the procedure for setting up of leveling instrument consists of fixing the instrument on the tripod, adjusting the height of the instrument and centering the cross bubble. Leveling up the instrument means bringing the bubble in the tube to the central position. The procedure for leveling of instrument is as follows. First, place the bubble tube parallel to any of the 2-foot screws. Bring the bubble to the center by rotating the 2-foot screws. Turn the bubble tube or telescope 90 degrees so that it lies over the 3rd foot screw and exactly perpendicular to the first position. Bring the bubble to the center by rotating the 3rd foot screw. Bring back the bubble tube to the first position, that is, parallel to the 2-foot screws, and check whether the bubble remains in the center position. If not, center the bubble again by rotating the 2-foot screws. Repeat the same process till the bubble remains in the center of the bubble tube, whatever be the direction in which the instrument is turned. So keep in mind, always follow these steps for leveling up of the instrument. For accurate sighting, parallax should be eliminated. It involves two operations such as focusing the eyepiece, turning the focusing screw. For focusing the eyepiece, look at the sky or white sheet of paper through the telescope and focus the eyepiece until the crosshairs are clear and distinct. Now, for turning the focusing screw, look at the staff through the telescope and turn the focusing screw till the image appears clear and sharp. Always remember, parallax is eliminated in 2 steps, focusing the eyepiece and turning the focusing screw. A permanent benchmark refers to a point with a known elevation above mean sea level, MSL. Usually, the permanent benchmark is far away from the site of the survey. In such cases, a piece of land or a pillar or a bridge can be considered as temporary benchmark. The elevation of the temporary benchmark is assumed to be 100. To know the difference in elevation between a given point and the temporary benchmark, first place the staff on the temporary benchmark and take the reading with a level. Note that you have to add 100 to this reading. Next, place the staff on the given point and take the other reading. The difference between the reading of the staff at the temporary benchmark and the reading at the given point serves as the transferred benchmark reading. In this way, the benchmark can be transferred from the temporary benchmark to the given point. The process is called transferring the benchmark from one point to another point. In this module, you have seen the types of adjustments required for leveling instruments and to transfer the benchmark from one point to another. The operation of temporary adjustment involves three major steps such as setting up of the leveling instrument in field, leveling the instrument, elimination of parallax. To transfer the benchmark from one point to another, subtract the reading of the staff at the given point from the reading of the staff on the temporary benchmark. You have seen that elevation at different points above a given surface can be determined by leveling. Do you know, depending on the requirements of the survey and the ground features, leveling can be carried out by different methods? So what are these different methods of leveling? Let us find out the answer by going through this module, Methods of Leveling. Welcome. After completing this module, you will be able to state the various types of leveling, explain the circumstances under which they are used, and their importance, plot the profile of a ground, and plot the cross-section. The various types of leveling are differential leveling, profile leveling, cross-section leveling, reciprocal leveling, and precise leveling. Now, let us know about the circumstances under which each of them is used and the importance of each. Differential leveling is used when we need to know the difference in the elevation between 2 points, whatever be the relative horizontal position of those points. Differential leveling is important as it helps us in tasks like finding out the difference in elevation between places like adjacent towns or cities. Profile leveling is used when we have to find out the elevations at several points on a line at fixed intervals of distance. Profile leveling is important as it helps us in the planning of structures like railway tracks, canals, water supply and sewerage lines, etc. Cross-section leveling is used when we have to find out, on both sides of a main line, levels that are perpendicular to that line, so that we can find out the vertical cross-section of the ground surface or of the layers underground or of both. Cross-section leveling is important for projects like road carpeting, excavation, etc. Reciprocal leveling is used when we cannot set up the level at any intermediate position. Reciprocal leveling is important when we are carrying out leveling over ground features like rivers and valleys. Precise leveling is used when a high level of accuracy is required. Advanced leveling devices are used to carry out precise leveling. Precise leveling is important in the planning of buildings, dams, industrial plants, etc. So remember, these are the various methods of leveling and their importance. You have seen that profile leveling helps you to find out elevations at several points at fixed intervals of distance along a line on the ground. In order to plot the profile of the elevation of the ground at each such point, a graph can be plotted, with the points taken along the x-axis and the elevation at each point taken on the y-axis. By joining the dots corresponding to the elevation at each point, we get an idea of the profile of the ground. You have seen that cross-section leveling is used when we have to find out the vertical cross-section of the ground surface or of the layers underground. In order to plot the cross-section of a ground, we can take the chain edge points along the x-axis and the elevation at each such point on the y-axis. By joining all the points of elevation, we can get an idea of the cross-section of the ground. Reduced level means the vertical distance between a given point and the surface of the benchmark or other reference level such as the mean sea level. There are two methods for calculating the reduced levels: height of instrument or height of collimation method, rise and fall method. In the height of instrument or height of collimation method, you measure the height of the instrument at every station. Reduced levels of points are calculated by subtracting the foresight or intermediate sight from the respective height of the instrument. The difference of the sum of backsights and the sum of foresights must be equal to the difference of the last reduced level and first reduced level. This is how you can carry out arithmetic check by the height of the instrument or height of collimation methods. The rise and fall methods refers to the difference of level between the two consecutive points. It is determined by comparing such points after the first with that immediately preceding it. If the result is positive, it falls under the rise column of the field book, and if it is negative, it falls under the fall column. When you have all the readings in your field book, you need to calculate reduced level by subtracting the fall from reduced level of preceding point. Once you have found the reduced level, you need to check the correctness by arithmetic check method. Thus, the height of instrument or height of collimation and rise and fall methods are used to find the reduced levels in the leveling survey. Typically, a level field book contains the columns such as backsight, intermediate sight, foresight, height of the instrument, rise, fall, reduced levels, and remarks. There are two methods for calculating the reduced levels: height of instrument or height of collimation method and rise and fall method. In the height of instrument or height of collimation method, you measure the height of the instrument at every station or field. Reduced levels of points are calculated by subtracting the foresight or intermediate sight from the respective height of the instrument. You have seen that elevation at different points above a given surface can be determined by leveling. Sometimes, though, the ground features are such that the task of leveling runs into problems. So which ground features cause these problems, and what are the problems of leveling? Let us find out the answer by going through this module, Problems in Leveling. Welcome. After completing this module, you will be able to solve the problems in leveling. Problems in leveling. The three main problems in leveling are leveling on a steep slope, leveling on summits and hollows, and leveling across ponds and rivers. Let us take a look at each of these problems. Leveling on a steep slope. Leveling on a steep slope is a problem because it is quite difficult to obtain equal backside and foreside distances along the slope. To overcome this problem, the level can be set in a zigzag route so as to obtain equal backside and foreside distances. For example, if AB is a line on the slope along which leveling must be carried out, then L1 and L2 are the positions of the level on the slope, and S1, S2 and S3 are the positions of the staff. So remember, to solve the problem of leveling on a steep slope, set the level in a zigzag route so that you can get equal backside and foreside distances. Leveling on summits and hollows. Leveling on summits and hollows is a problem because the placement of the level on the summit or on the hollow requires extra settings. This problem can be overcome on summits by placing the level on one side of the summit. In this way, the line of collimation passes correctly through the summit and there is no chance of any instrumental errors. Similarly, on hollows, this problem can be overcome by placing the level on one side of the hollow. In this way, the line of foresight and backside can proceed over the hollow without being disturbed. So remember, to solve the problem of leveling on summits and hollows, place the level to one side of the summit or hollow so that no instrumental errors occur and the line of foresights and backsides is maintained. Leveling across ponds and rivers is a problem because the level cannot be set on the surface of the water body. This problem can be overcome by treating the surface of the water body as a level surface. Drive a peg each on opposite sides of the water body so that the two pegs face each other exactly. Check and make sure that the top of the pegs are at the same level as that of the surface of the water body. After that, keep the level on one side of the water body facing the peg. With the staff held on the peg, take the reading. Now, you know the reduced level of the top of the peg and thereby of the water surface. Now keep the level on the other side of the water body facing the other peg. With the staff held on the peg, take the other reading. Add the staff reading to the reduced level of the peg. You will know the reduced level of the instrument axis and therefore be able to carry on the leveling task further. So remember, to solve the problem of leveling across ponds and rivers, take readings of the reduced level of the peg placed at the level of the surface of the water body and add the staff reading to it. Leveling on a steep slope. Leveling on a steep slope is a problem because it is quite difficult to obtain equal backside and foreside distances along the slope. To overcome this problem, the level can be set in a zigzag route so as to obtain equal backside and foreside distances. For example, if AB is a line on the slope along which leveling must be carried out, then L1 and L2 are the positions of the level on the slope, and S1, S2 and S3 are the positions of the staff. So remember, To solve the problem of leveling on a steep slope, set the level in a zigzag route so that you can get equal backside and foresight distances. Leveling on summits and hollows. Leveling on summits and hollows is a problem because the placement of the level on the summit or on the hollow requires extra settings. This problem can be overcome on summits by placing the level on one side of the summit. In this way, the line of collimation passes correctly through the summit and there is no chance of any instrumental errors. Similarly, on hollows, this problem can be overcome by placing the level on one side of the hollow. In this way, the line of foresight and backside can proceed over the hollow without being disturbed. So remember, to solve the problem of leveling on summits and hollows, place the level to one side of the summit or hollow so that no instrumental errors occur and the line of foresights and backsides is maintained. Leveling across ponds and rivers is a problem because the level cannot be set on the surface of the water body. This problem can be overcome by treating the surface of the water body as a level surface. Drive a peg each on opposite sides of the water body so that the two pegs face each other exactly. Check and make sure that the top of the pegs are at the same level as that of the surface of the water body. After that, keep the level on one side of the water body facing the peg. With the staff held on the peg, take the reading. Now, you know the reduced level of the top of the peg and thereby of the water surface. Now keep the level on the other side of the water body facing the other peg. With the staff held on the peg, take the other reading. Add the staff reading to the reduced level of the peg. You will know the reduced level of the instrument axis and therefore be able to carry on the leveling task further. So remember, to solve the problem of leveling across ponds and rivers, take readings of the reduced level of the peg placed at the level of the surface of the water body and add the staff reading to it. Summary. In this module, you have learned to solve the problems in leveling. The three main problems in leveling are leveling on steep slope, leveling on summits and hollows, and leveling across ponds and rivers. To overcome the problem of leveling on steep slope, set the level in a zigzag route so that you can get equal backside and foresight distance. To solve the problems of leveling on summits and hollows, place the level to one side so that no instrumental errors occur and the line of foresights and backsides is maintained. To solve the problem of leveling across ponds and rivers, take the readings of the reduced level of the peg placed at the level of the surface of the water body and add the staff reading to it.
You have seen the errors that are possible in leveling. In order to avoid some of those errors and other mistakes which surveyors might encounter on the field, it is advisable to be aware of some do's and don'ts in leveling. So, what are these do's and don'ts in leveling which surveyors need to be aware of? Let's find out the answer by going through this module, Do's and Don'ts in Leveling. Welcome. After completing this module, you will be able to list. The do's and don'ts in leveling are basically a list of precautions to be taken in leveling. Let's find out what they are. To begin with, always protect the threads of the tripod and the leveling instrument from injury. Lubricate the threads for easy motion of the screws. Don't let the lenses of the leveling instrument get dirty. Clean them frequently. Place the instrument properly in the box and do not apply the force on the lid while closing the box. Always check whether the foot screws are at the center before and after completion of the leveling work. Don't let the tripod legs become loose. Always tighten the nuts to keep them stable. While performing the leveling work, don't keep the instrument unguarded or left unattended. And also, don't keep the instrument on footpaths or road where anything that is passing may cause damage to the instrument. Do not keep the tripod legs too close or tool wide open. This makes the instrument unstable, leading to incorrect readings. Shift the instrument from one place to another by lifting the instrument onto the shoulder in such a way that one leg of the tripod is on your back and two legs face your torso. Don't take the readings on the staff which is too far. Always maintain proper distance between the staff and instrument to get the clear readings. Remember to always follow these do's and don'ts of leveling. In this module, you have learned the do's and don'ts that need to be followed in leveling. These are the do's or the good practices of leveling which you should always follow. And these are the don'ts or the bad practices of leveling which you should always avoid.
You have seen that the theodolite is an optical device which is a complex arrangement of many parts. So, what are the different parts of the theodolite and how are they arranged? What are the instruments required for surveying with theodolite? Let us find out the answer by going through this module, Parts of Theodolite and Scale. Welcome. After completing this module, you will be able to identify the parts of theodolite and state the instruments required for theodolite. Let us take a look at the different parts of a theodolite. Most of its parts are made of metal. The base of the instrument is a triangular plate called the trivet. The trivet is a plate with a threaded opening. The foot screws rest on the trivet by a ball and socket mechanism. These screws are used to level the device. At the other end, the foot screws are attached to a triangular plate called the tribark. The trivet, foot screws and the tribark are together referred to as the leveling head of the theodolite. Above the leveling head is the lower plate. The lower plate is also known as the scale plate. It is beveled and graduated with 0 to 360 degrees marked in the clockwise direction. Above the lower plate, there is an upper plate. It contains two vernier scales named A and B. Above the upper plate, there is the plate bubble. It is used to check whether the device is in a level position. On the upper plate, there is a pair of frames called the standard or the A frame. It supports the telescope of the theodolite. The telescope of the theodolite can be pivoted between the standards, perpendicular to the horizontal axis. The telescope has a focusing screw, clamping screw, and a tangent screw. Adjacent to the telescope, there is the vertical circle. It is fixed to the telescope and moves up or down along with the telescope. Beside the vertical circle, there are two verniers named C and D. Above the vertical circle, there is the altitude bubble. It helps in measuring the vertical angle. Sometimes, the theodolite is also fixed with a compass. It is used to take the magnetic bearing of a line. So remember, these are the instruments required for surveying with theodolite are chain or tape, ranging rods, arrows, and pegs. These instruments are helpful in marking survey lines and survey stations, as well as in measuring distances when carrying out theodolite survey. So remember, the instruments required for theodolite are chain and tape, ranging rods, arrows, and pegs. In this module, you have learnt the different parts of theodolite and the instruments required for surveying with theodolite. The theodolite is a complex arrangement of various parts, the important among them being the tripod, telescope, and frames, leveling head, vertical circle, and the plate bubble. The instruments required for theodolite are chain or tape, ranging rods, arrows, and pegs. We have already learnt about the parts and usage of the theodolite. Before using the theodolite, you need to make some adjustments to the instrument, such as setting up of the theodolite and centering, leveling the instrument, eliminating the parallax, that is, focusing. Now these adjustments are called temporary adjustments. Let us take a look at how they are carried out. The procedure for setting up of theodolite and centering is as follows. First, place the tripod over the station in such a way that the legs are spread out evenly around the station mark. Note that the head of the tripod should be directly above the station mark. Remove the cap on the tripod head and place the theodolite carefully on it. Rotate the tribrach of the device to fix it firmly on the tripod. Adjust the height of the tripod so that the telescope is at a convenient height of observation and use. After that, suspend a plumb bob from the hook beneath the inner spindle in such a way that it should be over the station mark. Check whether the plumb bob is precisely over the station mark by looking into the optical plumb eyepiece. Now, you have to level the instrument approximately by moving the third leg, while the other two legs remain pushed into the ground. Fix the tripod into the ground by applying force on the shoes of the legs. This way, the instrument is properly positioned and centered above the station mark. So remember, setting up the theodolite and centering means positioning the theodolite exactly over the station mark. Leveling the instrument. After having the instrument centered and approximately leveled, you need to level the instrument accurately. The procedure for leveling of instrument is as follows. First, place the plate bubble tube parallel to any of the 2 foot screws. Next, bring the bubble to the center by rotating the 2 foot screws either inwards or outwards simultaneously. Turn the bubble tube 90 degrees so that it lies over the 3rd foot screw and exactly perpendicular to the first position. Bring the bubble to the center by rotating the 3rd foot screw. Bring back the bubble tube to the first position, that is, parallel to the 2 foot screws, and check whether the bubble remains in the center position. If not, center the bubble again by rotating the 2 foot screws. Repeat the same process till the bubble remains in the center of the bubble tube, whatever be the direction in which the instrument is turned. So remember, leveling the instrument means adjusting it to an exactly vertical position. Elimination of parallax. For accurate sighting, parallax should be eliminated. It involves 2 major operations such as focusing the eyepiece, turning the focusing screw. Now, for focusing the eyepiece, look at the sky or white sheet of paper through the eyepiece and move it inwards or outwards until the crosshairs are clear and distinct. Now look at the ranging rod or other object through the telescope and turn the focusing screw till the image appears clear and sharp.
Today I will be discussing on Civil Services Conduct Rules 1964. It is a very important and relevant topic. Every central government employee should be aware with these rules. The central civil services are concerned directly with the union non-political executive administration and is the permanent executive body of the federal government of India. Every civil servant should possess the quality of being honest and should have strong moral principles. He should have loyalty and enthusiasm to duty, should not do anything which amounts to unbecoming of a government servant. It means he should behave in appropriate manner. Even neglect of wife or family by a government servant amounts to unbecoming of a government servant. He should behave in an independent and impartial manner in discharge of his duties. His behavior in both public and private life should be responsible, courteous and decent. He should aim to resolve public concerns promptly. He should follow proper lunch timings and should aim to set an examples to others. He should also report facts of arrest, conviction in criminal cases with respect to any government persons under their jurisdiction or with respect to himself. He is not expected to participate in political demonstration and should maintain political neutrality. He should act absolutely as per government policies. He should interpret the government policies correctly and implement them on ground in a letter and spirit. He should give respect to honorable MPs, MLAs while speaking to them or addressing to them. He should observe high regards to them. He should not be discourteous, dishonest and partial while delivery of his duties as government servant. He should not practice or propagate touchability in any form. He should aim to suppress such practices if seen in official decorum. Constitution provides a right to form association, but he should not or associate himself with any banned organization. He should always work for sovereignty and integrity of India. It should be his prime concern. His no act should harm the sovereignty and integrity of India. He should not participate in any strike. He is not supposed to take up any private work while in government duty. He should not take or give, even propagate dowry in any form. There is a tendency amongst government servants to use political influence in service matters like posting, etc. It should be avoided. He should not encourage use of drugs or drinks while on duty. Every child has been given right to education under the Constitution. Therefore, no children below 14 years of age should be employed. It is punishable offence. He should avoid anything which amounts to sexual harassment of women at workplace or otherwise. Under the CCS conduct rules, there are things have been given which amounts to misconduct. Therefore, while on duty, his any work which harm prejudice to the image of the organization or head of the organization amounts to misconduct. He is not able to live or work happily with the colleagues on duty. If his behavior amounts to not safe in public interest to retain him in service, if his behavior is not trustworthy, he is not able to maintain secrecy, if he is susceptible to attract something wrong or silly, if his behavior is abusive in routine working in office, if he does not obey the direction of his superiors and at times insult them directly or indirectly, any conduct of him which amounts to theft, fraud or dishonesty, his no action should cause any financial loss to the government. He should not take part in strikes, gheravs, even he should not aim to incite others to participate in such acts. He should not participate in riots or any disorderly behavior even after the office hours. He should follow punctuality in attendance and follow the leave sanctions. He should report a matter related to conviction by a criminal court related to himself or with respect to any colleague in his office. To bring more accountability and good governance, government has further brought amendments to CCS conduct rules in 2014. Most of the things we have already discussed, but government has further strengthened the rules to bring more efficiency in the government. Things are same, but certain things are added and elaborated further, like government servant should commit himself to and uphold the supremacy of the Constitution, his work purely in accordance with the Constitution of India. He should defend and uphold the sovereignty and integrity of India. His prime aim should be India's first. He should promote principle of merit and in an impartial manner. He should follow transparency. His aim should be to be responsive to public and particularly to weaker section of the society. He should show his concerns towards the issues of weaker section of society and should take proper steps to resolve them, to address them. His behavior in both private and public life should be good. Even the behavior with his wife or family, if bad, amounts to unbecoming of government servant. He should take decisions solely in public interest. More to say, what is most economical to the government, his decision should be according to that. He should aim to use public resources very efficiently and economically. At times, it may happen that there is a conflict of interest in his private and public duties. Whenever this happens, it is aimed that the government servant should declare his private interests which are conflicting with public duties. While in duty, he should not place himself under any financial obligations directly or indirectly which influence the organization. It has been seen in MES that certain officials sign the loan papers of banks, and at the time of default of individuals, bank approach to the organization to repay their loans. It is not allowed to any government servant to sign such papers and bring liability or obligations to the organization while performing his duties. His any work should not amount to bring or drive any financial or material benefit for himself or to his family or his any close relatives. He should make decisions in objective manners, and his decisions should be based on the merit of the subject rather than with influencing with any partiality. He should not discriminate among anybody, whether it is on caste, creed or economical backgrounds.